So this video is the second video to rational expressions. So in the first video we looked at addition or simplifying rational expressions through addition and subtraction. So in this one we'll look at multiplication or simplifying them through multiplication and division. So let's see some examples on how to do that. Okay, so you will have to know how to factor. So if you need a review on factoring quadratics, make sure you go and look at those videos. Okay, so to simplify this expression here, we have the quadratic on the top and quadratic on the bottom. So what I'm going to do is I'm going to factor both the numerator and denominator. So if I factor the top quadratic, what I get is, I'm looking for two numbers that multiply to -6 but add to +1. So that would be -2 and +3. So x minus 2 and x plus 3. And then if I factor the denominator, I'm looking for two numbers that multiply to +15 and add to +8. So that would be 5 and 3. So I have x plus 5 and x plus 3. Okay, so then what happens here is I just can cancel the common factors because everything, I have terms that are being multiplied together or binomials that are being multiplied together. So I can cancel anything that's in common. So I have an x plus 3 in the numerator and an x plus 3 in the denominator, so I can get rid of those. So this expression simplifies to x minus 2 over x plus 5. Okay, I should also list my non-permissible values. So remember that's what makes the denominator equal to 0, but I have to go back up into my original equation, or I can go back, my original expression, or I can go back to the one that I factored so I can easily see what would make the denominator equal to 0. So my non-permissible values are x cannot equal -3 or -5. So make sure you go back to this stage up here so you get both those values and not just looking at your final answer. Okay, let's see another example. Okay, so this one I have a compound fraction. I have 1 over n plus 9 all over 6 minus n over 3n minus 18. So the first thing I want to do is when I'm dividing fractions, remember what you want to flip the second one or the bottom one and then multiply by it. So I'm going to take this guy up here and multiply by 3n minus 18. So I get 3 over 6 minus n. Okay, so I flip the bottom fraction and I multiply, so now I'm just multiplying the two things together. So with this, what I'm going to do is, again, I'm going to look to see if I can factor, so always look to see if you can factor anything. So in the expression on the right, in the numerator, I can factor out a 3, so I'm left with 1 over n plus 9, I'm not changing this one yet, times, and I'm going to drop that dot, I'm just going to put this here. So factoring out a 3 in the numerator, I'll be left with n minus 6 all over 6 minus n. Okay, so again, I'm looking to see, can I cancel anything in each of the brackets separately, or can I cross cancel because I'm dealing with fractions? So if I look at this on the right here, I have in the top, I have an n minus 6, and in the denominator I have a 6 minus n. So what I can do there is in the top, this is a good trick, or in the bottom, it doesn't matter, you can pull out a negative sign to reverse the order those are coming in. So if again, I'm not going to change the first, 1 over n plus 9 stays the same, and I'm going to factor out a -1 from the n minus 6, so I have -3, and that flips the order of this, so 6 minus n over 6 minus n. Okay, so that's a really good trick because now both those are in common. So the 6 minus n on the top and the 6 minus n on the bottom. So now I can cancel them out. So now I'm just left with 1 over n plus 9 times -3. So that would just simplify to -3 over n plus 9. Okay, And then again, I should state my non-permissible values. So I have from the very beginning up here, I have that n cannot be equal to -9 or 6. Okay, let's see another example. Okay, so I'm multiplying these two rational expressions together. So again, I'm just going to look, can I factor anything out of each one separately first? So yes, on the right, I can see that I can do some factoring. There's some common terms in this guy here. So I'll leave the first one the same. And on the right, I'm going to factor out a 3 from the top. So I have x minus 6, and then a 3 from the bottom. So I have 3 times x plus 3. Oops. Okay, and then look at each one separately. Can I factor anything, or can I cancel anything out? So I can cancel these 3's out here. Okay, so now I'm left with x plus 3 over 4 times x minus 6 over x plus 3. I can drop the brackets, the inside brackets on this guy here. I don't need them anymore because there's nothing being multiplied by them. So now I'm looking to see if I can cross cancel anything in common because I have a fraction times a fraction. So I see that I have in common an x plus 3 and an x plus 3. So these would cancel each other out. So there I'm just left with x minus 6 over 4. Okay, and then I should go back and state my non-permissible values. So this is true so long as x is not equal to, back to my original, I can go back to this one or where I factored it out there, so where x is not equal to -3. Okay, and last example. Okay, so I need to factor both the numerator and denominator. So anytime you're trying to simplify rational expressions, the first thing you want to look at is factoring. So I can factor both the numerator and denominator in this case. So the top is easy to factor. I'm looking for two numbers that multiply to -80 but add to +2. So that would be +10 and -8. And again, it doesn't matter what order I put them in there. And then in the denominator, I can factor out a 2x, because that's common in all the terms. So I'm going to do that first, and then I'm left with x squared minus 12x plus 32. Okay, so now I have a quadratic in here, so I can factor that as well. So I'm looking for two numbers that multiply to 32 but add to -12. So that would be -8 and -4. So then I have x minus 8, x plus 10, all over the 2x stays in front. And then I said I factored this into x minus 4 and x minus 8 will work. And then because everything is being multiplied together, I can cancel things out. So I have an x minus 8 on the top and an x minus 8 on the bottom, so I can cancel those. And that's all I have. So now my rational expression simplifies to x plus 10 over 2x, x minus 4. And as long as x is not equal to, so I'm going to go back to the, before I canceled anything out, to the factored expressions here. So x can't be, well, 0 would be bad for 2 times 0, so it can't be 0, can't be 4, and it can't be 8. Okay, so whatever would make the denominator 0 wouldn't work. I'm just going to make one extra quick note here. If you have something like, okay, I'm going to erase some stuff here. Let's just get rid of this. So this is a common mistake that I see a lot when students are trying to cancel terms out or simplify expressions. So if you have something like x plus 3 over x minus 2, say just something simple like this. So this is different from this example here. What students often will try to do is they'll try to cancel these x's out like this, which you can't do because they're not being multiplied or divided. they are part of a linear term here with the plus or minus. So just be careful that you never ever do that and that you're only canceling out common terms or common factors when you're multiplying or dividing things together. Okay, that's it. Thanks for watching. Good luck with the assignments.